All right, kids. Hey, happy Thursday. Welcome back, sixth graders. I want to talk to you about the conic or about composite shapes again. I got a couple other things I wanted to discuss today and show you how to do. I'm going to go through these diagrams. I'd like you to sketch them out, but here's what I'm going to ask. I have 2 pages of problems, and I have 4 problems on the first page and 3 problems on the second page. I'd like you to do 2 of them from each page in your notebook and then submit that to me. So as part of your note cards for this week, 2 problems from each page. Now I'm going to go through, I think, 3 of them on each page. I'm going to go through 3 of them right now and show you how to do them. You're going to copy down 2 of them from each page. So let's get to it. And by the way, the reason I'm doing this is a lot of the Khan Academy for this week, I'm going to assign it today. It's not very difficult. It's not very long, but some of the problems I'm going to touch on, especially these purple ones, are just like the ones you're going to see from Khan Academy. So I want to talk about how to do them. So let's kind of get at it. I'm going to try to make this video hopefully a little shorter, but we have a lot to do. So here's the idea. On this one, we have a trapezoid. A trapezoid because it's like, 2 sides are parallel, but the other 2 sides are not. But what we're going to do is break this into parts. And to break it into parts, you see here there's a rectangle, and here there's a triangle. So what I'm going to do is draw this line to separate the triangle, right? So that's the triangle. That's a right angle right there. And what we're going to do is say, well, that 20 represents the entire length of this bottom shape. Now, the problem is, in order for me to find a triangle, what I really need to do is know what's happening right here on this length, right? That's what I need, and that's what I don't have. But to find that, and we're going to, like I said, we're going to go pretty quick. What I have to do is say, well, if that whole length is 20, the entire bottom, and I know that this length is 9, right? In order to find out how far this is, I can basically say, well, I know that down here by transference that the bottom of this one, or this bottom of the rectangle, is 9. So that means over here, the bottom of this one has to be 11, right? Because 20 minus 9 is 11, or 9 plus 11 would give me 20. So if the whole thing is 20, which is what that 20 down there means at the very bottom when we started, then that means that the beginning of this thing, right, must be that one side is 9, one side is 11. So now the other interesting thing is this 14. Do I need it? Well, I never need this side. I don't need it. It's unimportant. So I can just cross that one out. I don't need it, but I do need the height. So also through transference, I can look at this and say, oh, if this side of the rectangle is 11, that means this side also is 11. And now I've got what I need. I've got a base and a height for my triangle, 11 times 11, and I've got a base and my height for the rectangle, 9 times 11, right? So my triangle is 11 times 11 divided by 2. My rectangle is 9 times 11, and I add them together. And we've talked about that, so I'm not going to go through all the calculations there, but think about how to find those missing sides. So there you go. That's one problem. Next problem. Take a look at this one. This is some weird combination of a triangle, a trapezoid, a rectangle. There's lots of ways to break this up. But essentially, what we want to do is talk about this triangle that's setting within right here. That's the one we want to look at. How do we figure out what that is, right? Like, and one way to think about that triangle is to say, well, I don't see any dimensions on it, none at all. Nothing jumps out at me. So what I need to do is figure out this one and that one. Now think about it for a moment. I know that this whole side is 5, and I know this partial side right here is 2. So if those two add up, like if that one's 2 right there, that means the rest of this vertical line must equal 5 when I add them up. So like for instance, and I'm going to do this. I'm going to connect this here. That 2 by transference would also be here. So if that's 2, it means the upper part of this must be 3. I'm going to try to write it over. So the reason that's 3 and 2 is because the entire side from top to bottom must equal 5, right? Because of this number right here. So because of this number, this 5, it means all of that must equal 5. And that's 3 plus 2. And that 2 is there because of transference over here. Okay, so that's how this works. Now the same thing is true of this second line, the one we don't know, this one, the height of that triangle, or you could say the base of that triangle. Now once again, what are the numbers I know? Well, I know that that 5 right up there is also going to be along this side. So if this entire length is 9, and I know through transference that this thing is 5, right? Then I know that the other side of this straight line must be 4, right? 5 plus 4 equals 9. And if that's 4, then this kind of question mark right there, or that little thing right there, is got to also be 4. So these are pretty small. I know they're pretty small. But what I'm trying to get you to understand is that you can kind of use this idea of transference. And I don't know if I can, let me see if I can erase this. Oh, that's funny. It makes the whole thing gone. That's not all that helpful. The whole idea of transference tells me that like we can figure all of this out now. So now what do? Well, my square right here is 5 by 5. So the area of this, right, the area of that equals 5 times 5, right? The area of this part, right, equals 2 times 4. Remember, we only have to do the base and the height. So this area equals 2 times 4, or 4 times 2, so that's 8. This one's 25. And the area of this one, the triangle, equals the base times the height, 4 times 3 divided by 2. So here my area equals 4 times 3 divided by 2. Okay, does that all make sense? Pretty cool, right? And then, so that's the second one. That's complicated, but you're going to see one like that on Khan. So take a look at that again. Take a look at that again and see if you can figure out. I'm going to show you one more here. On this one, I have these little symbols. Do you see the symbol? That line and that line? What that means is that those two are exactly the same. Okay? And we're going to talk about what that's important, because what that means is that the line, if those two are exactly the same as each other, those two lines mean they're the same, that means that I can also draw this dotted line here and know that each of those triangles, the one on this side and the one on that side, are the same. They're equal. They're just a reflection of one another. So if 15 is going from this edge all the way to this edge, right? Then I know that, and I know that this down here is 5. That means I know that the line in between here, this has got to be 5. And that means that these two also have to be equal, because those are equal. It means that this has to be 5. And this also has to be 5. And the reason that is because 15 into those three parts, if they're all equal, and I know they're equal because of this whole thing, these two triangles being the same, right? Then I know that they're all 5. And now what do I know about the height of this last triangle over here? Well, I know through transference that it's going to be 6, right? So now I can find the areas. The area of the middle square, which is a little tricky. I know there's a lot going on here. The area of the middle square is 5 times 6. The area of this triangle right here is also, look at the base and the height, also 5 times 6, but you got to divide by 2. So area equals 5 times 6 divided by 2, right? And the area of the last triangle is exactly the same as that. So the area over here is the same as it was over there. We have 5 as a base and 6 as the height. So the area of this side is 5 times 6 divided by 2. Now, I know these look complicated, but what we're really looking at is, can you start to transfer things across a form? Okay, I'm going to pause this for a second and then come right back for the second page. Like magic. Did you guys see that? I'm in a new place. Look at that. Brand new place. I just move locations. I can just what's it? It's like Star Trek. I just fade in from one place and fade into another. So now I'm in my sunroom. So you like that? Just pause, new space, new space, new space. Now they needed that dining room that I was sitting in, so I had to like pause it and move over here. All right, so back to this thing. We're gonna not worry about this one now. We did more like that before, so we'll wait on that one. That one's an interesting one, but we can wait on it. I want to show you at least one more on the second page. So on the second page, we're going to look at a couple of these, maybe two more. I'm going to try to wrap this up pretty quick, but let's take a look at how this one works. Once again, these are in Khan Academy. The purple ones are from Khan. I'm just kind of playing with them, like showing you now. But I want to show you on this one, we have all these triangles. Now, there's a triangle here, a square there. You know it's a square because it's 2 by 2 by 2, right? So it's 2 on all sides. And that also means that if I continued this square from there to there, that dimension would be 2 again because of transference. If this is 2, that's got to be 2. So now I look at this one and I say, what is the dimension of this big triangle, right? So I would say the area of this one would be the base, which is 2 plus 2 plus 6, which is 10, right? So the area is 10, which is my base. That's my base right here, times 4, which is my height, right? Base times height divided by 2, and then divide by 2. So that's how I find the area of the big triangle. The other triangles are really simple. You have everything you need. So the area right here is also a triangle. So you go 6, which is my base, times 2 divided by 2. So 6 times 2 divided by 2, right? And that's easy. The area of this little guy over here, 2 times 2 divided by 2, right? And that's all kind of weird, but we have lots of 2's. So 2 times 2, and then because it's a triangle, you got to divide by 2. So that'd be pretty easy. And then the last thing, the one we haven't done, the whole part right here, is going to be that's just a square. So that one is an area of 2 times 2. Now, what do? We figure all these out and we add them together and we've got all the parts, right? Isn't that cool? Like, it looks like a complicated problem, but we can do this. Now, a couple other really simple ones. This one, how do we break it up? Well, we'd break this up into a pointy, it's like a pencil. We'd have basically 15 times 20. That's one part, right? So the area here is 15 times 20. I know 15 times 10 would be 150. So 15 times 20 would be 300, 150 plus 150, right? And then the triangle. Now the triangle is interesting. We know the 10 right here. Wouldn't that also be the same as our height? Like, isn't our height right here going to be 10? So it said 10 right there. So that means this is 10. And then that means this part right here, the base of that triangle is 15 because of transference. So if I take this 15 yards, I move this over here, my entire base is 15. So the area of the whole triangle, this isn't just one half, the whole thing, right? All of this, right? Is going to be area equals 15 base times 10 divided by 2. And I know that's 150 divided by 2 is 75. So the area is 75. The area over here we already said is 300. You put them together, right? So that's how this one works. That one's pretty simple. I don't think that's that hard. And the last one I want to show you, let's take a look at this one. Once again, break it up into the triangle and the rectangle. What we don't know, we know this rectangle is 6 by 3. So the area down here for the rectangle is 6 times 3. That's pretty straightforward. It's a rectangle. But the triangle is a little more complicated. So we bring this 6, we transfer it up to here. So this dimension is 6, right? And over here, we say, wait a second, I don't know what this is. But then I say, wait, this part was 3. That means that through transference, this inside part here is 3, which means in order for the entire thing to be 6, they both need to be 3. So now I find the area here, and I say the area here would be base 6, so equals 6 times 3 divided by 2. Okay, so, and we figure it out and we solve it. And your job, pick 2 from each page, 2 from this page, 2 from this page, and just copy it down in your notes, okay? So you have it there, so you see it, because once you watch the video, it's gone. That's why I'd like you to get 2 of those copied in your notes. Put them into your note cards for this week. Call it practice, right? Just or call it Thursday note cards. So what's today? 5/12, 5/13 on Thursday. All right, my friends. I hope you like how I can magically move from one space to another. And for one more magic trick, I just transformed into Elliot. It's amazing! Oh, amazing! Different room, different place, different person. I can do anything. I am what is this? It's a whiteboard video making genius. All right, kids, I hope you enjoyed the video. Have a great day. I will see you soon.